Imagine being a customer of a website for booking amazing trips. But it's 2025, right? So you open your favorite LLM chat, ChatGPT, Claude, Gemini, whatever. You quickly authorize your favorite website and you add a prompt. I want to go to Portugal and spend a romantic weekend around the middle of July. Book me a spot in a 5-star hotel. Just make sure the weather is great. Please. You wait a second for the assistant to do its magic, and it's done. You hear a sound of a new email message incoming. It's a booking confirmation for your next trip to Viana de Castelo. Well, wouldn't that be just amazing? And would it be even better if the website was running on a Ruby framework, like Rails? In order to make this dream come true, today I'm going to tell you how to make Rails AI ready by design with Model Context Protocol. Hi, I'm Paweł Strzałkowski. By day, I'm the CTO of Visuality, Ruby agency from Warsaw, Poland. I've been a developer for more than 20 years and was involved in over 100 projects. And I always find something creative and interesting in each one. And depending whether your heart calls for code or business, you can find me on GitHub or LinkedIn. So let's start. Let's start with a brief introduction to what Model Context Protocol is. So the internet is full of applications, right? Well, you are the ones who build them. And on the other hand, we have an explosion of LLM-driven solutions. Yet, there is a thick wall between LLMs and traditional websites. LLMs have no power to connect to live systems on their own, at least. Well, we could make up for it. We could program, let's say, chat applications so that they use tool calls to act as gateways between LLMs and APIs of existing applications. It can be done, and sometimes it's definitely the way to go. However, doing it on scale, we quickly arrive at a situation called M times N integration problem, where you have M models and N solutions, and every time you want to add a model or a solution or service, then you have to program for each and every one of the others. It's just a very large overhead and simply the wrong tool for the job. And for sure, doesn't feel AI native. On that note, in order to enable live interactions between LLMs and web applications, large language models need to be provided real-life context over an AI-native protocol. Well, such protocol has been created and, of course, was called Model Context Protocol, MCP in short. So what's MCP? It's an open standard. That means it can be used, implemented by any of you. It has been introduced last year in November by Anthropic, and once it got some traction, it was backed by the biggest players, by Google, by OpenAI. And there are so many one-liners in the internet saying what MCP is, and honestly, none of them is true or accurate or explains anything. So I have my own one, so I'll try. So MCP standardizes the way of providing additional context for LLMs. And this additional context includes providing interactive, real-world, up-to-date, current context. Let's take a look at the architecture of a system using MCP. The central piece is often forgotten, but it's called MCP host. It's a user-facing application. Your ChatGPT, your Claude desktop AI, or Cursor, for example. The host application communicates with LLM using prompt and response schema. Now, MCP servers provide context to a host over HTTP connection. In some cases, as Jose mentioned, server may run on the same machine as host, and then they communicate over standard input-output. But it's not the case for us today. I'm going to talk about the over HTTP connection. So MCP host fetches context using MCP client libraries. And every time this host sends a prompt to LLM, it adds the context loaded from the server. Now, I've said that MCP servers expose context so many times by now. But what is the context? The context is built of so-called primitives. The basic primitives are, first of all, tools. Those are capabilities of the server. What the server can actually do. For example, forecast weather for a given location and date, or publish an article over a given ID. So whatever the server can do is there as a tool. On top of that, we have resources, basically data, files, records, logs, images, you name it, whatever you need. Third basic primitive would be prompts, standardized recipes for users. So MCP can provide a standardized recipe for a prompt for a user to be given by MCP host. Now, knowing the primitives and the architecture, we can quickly go over what happens during a single simplified use case. Let's use a travel agency web app and a weather forecast web app. So we start by initializing a host application. We turn it on. Host application uses MCP client libraries to fetch primitives from configured MCP servers. So we fetch tools. In this example, we fetch tools and resources from travel agency MCP server, and we fetch tools from weather forecast MCP server. What's next? User enters a prompt. Book me a romantic European weekend trip, just make sure the weather is good. This prompt is sent to LLM with all the context, tools, and maybe resources. Now LLM returns its answer, asking the host to call list romantic trip tools. As a result, the host application calls the MCP server to execute this list romantic trip tool, and server replies with a list of possible trips. And this response is a new element of the context of the conversation. Now, this newly acquired list of trips is added to the previous prompt, and everything altogether is sent again to LLM. And now, LLM responds with a series of tool calls, asking to call get weather forecast 3 times, each one for a given city. Host makes 3 tool calls and asks the weather MCP server for the 3 forecasts, each time getting a response. And finally, host application sends the previous conversation plus the weather forecasts to LLM, and this time a success. LLM says to call book trip tool with ID 41. That's Viana the Castelo. The example ends here, should continue for 2 iterations, where finally we would provide the user with an understandable answer, but we got the gist. LLM was interactive with a real live application. And you may control multiple, as a user, you may control multiple applications using just plain language, as I showed you. It's the LLM's role to plan complex, multi-step procedures. So guys, how can we build an AI-ready website with MCP server? First of all, we need a new H framework. So I would propose to use this one. And let's recreate the most famous Rails app as an MCP server. Let us once again build a blog engine, but this time let's add MCP server capabilities to it. Let's also make it AI native. All right, so every new Rails application starts with Rails new. It would be the best if to have an option to put Rails into MCP mode, maybe like this. But we don't need the framework to include a single recipe. I've prepared a template, which I'm sharing in this QR code, and it adds a few elements to default Rails installation. First of all, it adds a gem. It's the official SDK. You don't have to use official SDK, as we've learned today, but it's quite useful. It adds some additional things, which I'll go over in just a second. So we have a blog application, and I applied this template. You can clone it from my Git repository. Just open the QR code. It will be visible on my later slides as well. So when you apply the template, it adds several new elements to your Rails application. Among others, it adds MCP server endpoint, so controller and some routes. Templates adds an MCP hook to scaffold controller generator. So whenever you scaffold an active record model, it also scaffolds a new MCP tool and its CRUD actions. I will go over that in just a second. I've also added a new generator called MCP tool generator. You can scaffold any MCP tool with that. So we've initialized a new Rails application, right? And we've put it in MCP mode. Let's see what we've got. So we start at the classic Rails server. Nothing new in here, just standard frontend as we all know and love. But we can also run another program called MCP Inspector to debug our new Rails MCP server. So we just select transport type that was mentioned, and we put our localhost 3000/MCP. And we hit connect. And the best part is, it's green. We are connected. There are no tools, no prompts, no resources yet. But out of the box, with Rails and a single template, we have ourselves a running MCP server on Rails. To follow the classic story of the blog application, we should now scaffold posts, so let's do it. Again, at the first glance, almost nothing new in here. We run Rails, generate scaffold post, post has a title and some body. Just notice that apart from traditional files, we also have 5 tools for 5 CRUD actions. Let's run the migrations. And let's just run the server and let's add a single post. It will be useful for the next tests. All right, so let's review some of the elements created out of the scaffold control generator. The template we applied includes an additional rake task. Of course, it's called MCP tools. It lists all the defined MCP tools. It lists their names, descriptions, and input schema. We can also see the new tools in MCP Inspector, of course. Let's run it, maybe. All right. So let's reconnect to the server. And now we can list the tools, and here they are. Let's start with index, which lists last 10 items by default. Of course, now we have only one. We can update it with new data. It feels like using a typical Rails form or maybe like API, but it's communicating over a model context protocol, which we'll see in action in just a second. We can also fetch a single post. So, okay, we have some MCP tools. Let's look into the code a bit. Here's one of the tools for creating a post. The input arguments match those of active record model. And the tool also gets a default name and the default description, everything that it needs to be working in MCP. It also has basic error handling. All right, but the most famous application doesn't end on posts. Let's add some comments. So a comment references a post and has some content. It's content, yeah, and it's a text. So again, tools are generated alongside. We can run, of course, migrations, and we can run the same MCP tools rake task that we had before. And now we can see that we have both MCP tools for posts and for the comments. Again, one for each CRUD action. All right, let's take a look into the source code a bit more, because this is a bit more interesting now. Now we have a comment create tool, and you can see that apart from, for example, content, it includes a post ID, as active record model would, right? So whenever we want to create one, we have to say to what post it belongs. Another tool might be for the index. We can list the last n by default 10 comments, but you can find that it has post ID ability. It has the ability to filter by post ID as well. So you can ask for comments belonging to a post. And one more, a simple tool just to fetch a single comment. We just have to provide ID. All right. Hotwire wasn't in the original application because there was no Hotwire back then, of course, but I want to add it just to show you how the server behaves when we interact from an LLM application. So this is really not that important. So at posts index view, I've added a turbo stream called posts, and I converted the listing to a single partial called posts, which lists all the posts and all the comments with all the details. And of course, whenever a post is changed, I broadcast this partial to post stream, and I added touch to comment just so whenever a comment changes, it should also touch. Well, it should touch. So therefore, update the post it belongs to. And on top of that, I've just exposed posts at the root path. All right, so since I want to show you like almost production level software, let's put it in production. It should be quite easy. We have Rails, and we want to test in production. So I have a domain, which is in fact my wedding anniversary date, and I have a VM at DigitalOcean. I updated camel configuration. This is all you need. This is like all the update that you needed for default deploy YAML. I committed the changes to Git, run camel setup, camel deploy. In minutes, barely in minutes, it's online on production. So it's showtime. Let's see how it works. So this is our page in production. I open Cloud Desktop. I wanted to use a customer-facing application, not a developer tool. And I asked it to write a short post about a city in Portugal, which it of course does, but not through MCP, because I haven't connected that. Let's go to connectors. Let's add a custom connector. I just put the name and the URL. Of course, URL/MCP. It connects. I can see all the tools that we've scaffolded from our Rails application. And now we can use it. So let's ask it once again to create 3 posts about cities in Portugal. And now it wants to use a tool. Well, for security reason, each time a new tool is used, it asks for permission. But here we have it. With Hotwire, the post has been shown right away. And it will write 2 additional posts. Now it won't ask for permission because I clicked Allow Always. So we have Porto, we have Lisbon, and 1 more. Yeah, great. Well, we have quite a few other tools. So let's ask LLM to comment on some of those. But let's make it a bit more difficult. Let's comment on the post about both Porto and Lisbon. Comment create tool. Here we have it. The first comment is there. And we have another one. Let's delete the other post. No comments, so we don't need it. By the way, this page is still live if someone wants to play with us. I think you can break it quite quickly, but it's live. Now let's update the comment about Lisbon. Let's make it more intense, or how I call it, LinkedIn ready. So, yeah, allow, and of course we have capital letters in the first sentence. So, yeah, here it is. So guys, this is how you turn your Rails application into MCP server in 5 minutes. But if you ask me, is this the way? Should tools really implement CRUD? Well, the short answer is no. But actually, guys, remember that the magic of Rails began with CRUD. And we had to learn how to build web to reach IPO-ready applications. So let's allow ourselves a bit of fun. And let's learn MCP through those basic tools. Because yes, tools shouldn't be CRUD only. LLMs aren't great at using a big number of tools at the same time. We should aggregate. We should aggregate bigger functionalities into tools. But let's start with CRUD, and let's learn as we go. But as I mentioned, not every tool has to or should come up from active record behavior. So let's scaffold a weather check tool. Just an example. So I've mentioned that there is another MCP tool generator. So we can use it with a simple instruction. When we run it, we get a single file. And it looks like this, like without white space, of course. It has all the parameters that we've provided. It has the name, it has the description. We just have to fill in the logic, which could look like this. In here, I'm using API for the weather to come from third party. Now, we could see how it behaves in Claude, but I have something that would be a bit more fun. So before we see the new tool in production, I want to show you one more thing. So far, we've built an MCP server in Rails, and you already know that you only have to apply a single template and you have it almost out of the box with scaffolding. But what about MCP host? Do you know that in Ruby we can also write it with Rails and that it's not even hard? When building MCP host application, in order to handle user prompt, we need an endpoint, one endpoint in fact, and a procedure of actions, let's say. So we have to take the prompt, instantiate MCP client, load the tools and other resources from server, send the prompt with tools and context to LLM, and then handle. Whenever LLM wants to ask to call tools, we call them. And whenever it doesn't, we finish the conversation. That's like the simplified version of an MCP host. By the way, my version of MCP host on Rails can be downloaded from here, from my repository. It will be there for like 10 slides, so you can take a look. So let's break it down. We instantiate MCP client library, and this is a great gem, which I've used for this. There are different gems. This is one of them. You just provide the URL of your server, and you're done. Then, as we've learned today, we put some system prompt, we add a user prompt, we take MCP client, we load tools. In here, there's the command to OpenAI tools, because I'm using GPT, and we send it to LLM. We take the assistant message out of the response, and we extract tool calls. Yes, probably it would be much easier with Ruby LLM. You can use it, of course. And if LLM responses with null tool calls, we just render the response from the assistant. However, if there are tool calls, we iterate over them, and we call MCP server through MCP client for all the tools. And remember, MCP-driven conversation is all about keeping context. So we should probably store all the messages and all the tool call results in our message memory. And once it's done, let's ask LLM again. We've run the tools, we got the results, and now we have all that in the messages variable. So let's send that again to the LLM. And once again, if there are additional tool calls, we run them. If not, we just respond to the user. So let's use our MCP host application, and let's see how it would interact with the server we've just created. So we still have our page in production. Now I open my MCP host written in Rails, and yes, it's a PWA. It already has the server configured. We can view tools. At the very bottom, we have the check weather tool that we added, but it has no context of the existing post, so it would have to fetch it first. And I asked it to write a post comparing the current weather in the cities I wrote blog posts about. So it doesn't even know what the cities are. So first it asks for post index tool, just to fetch the posts. Then it wants to check the weather. First in Porto. And then in Lisbon. And now it wants to write a post. And here we have it. It loaded all the context that it needed, checked the weather, and wrote a post. And we are ready. Applications has been, well, generated, models and tools scaffolded. We've deployed with Kamal, used with a customer-facing application, Cloud Desktop. And the host app, well, it has been vibe-coded mostly. Just the most important logic was written by me. So how can it be so easy? I'd say it's the flexibility of Ruby on Rails. You can do almost anything with this framework and with the language, of course. And I'd say, even with Dark Screen, that I was standing on the shoulders of giants, so maintainers of open source software. The creators of FastMCP, ActionMCP, and RubyMCP client, I've spent hours, well, days with them, and they taught me what's MCP, how it interacts with Ruby and Rails. And of course, the maintainers of the official Ruby SDK, I used this gem for the template for Rails, so big thanks to them as well. So what's next? Of course, authorization. MCP says use OAuth, but it's not the role of MCP gem to say to the application how OAuth should be rolled out. So I leave that to you. And on top of that, there are many more primitives. Tools are the most, let's say, sexy ones, the ones that got MCP going. But there are resources prompts, as I've mentioned, but there are other, like somethings, completion, and all that makes a much better MCP experience when you implement it all. But I leave it as an exercise to you to connect them with Rails. And I would just like to leave you with one more thought. With Ruby, we have all the tools that we need. The language is so flexible, and the tooling actually is mature enough to write it all and to have fun with it all. Just stay creative, please. It's much more fun to be creative. Thank you.